Hello, geometry students. In this video, we're going to talk about section 1.4 from chapter 1. This section is going to talk about pairs of angles. So when I talk about pairs of angles, I'm talking about two angles at a time. So we're going to talk about the different types of angle pairs we can have and how we can use them to solve some problems. So if you're watching this video, most likely I am not here or we're doing some kind of a flipped activity, but we can use this video regardless. So let's go ahead and get into it. First off, some vocabulary. So we're going to talk about complementary angles and supplementary angles. All right, so let's go ahead and start with complementary angles. So complementary angles are two angles whose measures have a sum of 90 degrees. So in this example here, angles A and angle B are complementary because the two angles add up to 90 degrees. I can take the measure of angle A and the measure of angle B, which is 53 plus 37, and I'm going to get 90 degrees. Okay? It is not two angles that are 90 degrees. It is two angles whose sum adds up to 90 degrees. All right, the next one would be supplementary angles. Supplementary angles are two angles whose measures have a sum of 180 degrees. And in this example, angles A and angle C are supplementary because I can add 53 to 127 and I will get 180 degrees, okay? Again, I'm focusing in here on the word sum here because a lot of times in geometry the first time around, people think complementary angles are two angles that are 90 degrees, not add to 90 degrees. Make sure you know the difference, okay? Two angles that are 90 degrees are just two right angles. All right, and an easy way to kind of think of this is think of it alphabet-wise, right? C comes before S, 90 comes before 180. So complementary goes to 90, supplementary goes to 180. All right, so this is your next section here in your notes here. I just want you to kind of think of, so we're going to take these angles here and see if we can come up with an expression to find the complement. Well, when I say the complement, I just mean the other angle. So we're given an angle 30. What is going to be the other angle that would add to 90? Well, we can do this by taking 90 degrees and subtracting my 30-degree angle, which in this case would be 60 degrees. So we would say that the measure of the complement angle is 60 degrees. Now think about it. A nice way, double way you can check it. Does 60 degrees plus your original angle over here add up to 90 degrees? Well, 60 plus 30 is definitely 90 degrees. And we can do it like so. So if I wanted to find an expression for a 45, I would take 90 degrees minus 45 degrees. I would get 45 degrees. I think you guys are getting the hang of it. To find the complement of a 60-degree angle, I can take away 60 from 90, and I'm going to get 30 degrees. Regardless, when I'm trying to find the complement of an angle, which is the other angle that adds to 90, I can take 90 degrees and subtract whatever that angle measure is. So the measure of a complement for any 90 degrees minus x. 90 minus x degrees is how to find any complement, right? Subtract from 90 if you don't know it. So in general, you can find the complement of an angle that measures x degrees by subtracting its measure from 90, or 90 minus x degrees, okay? Similarly, I know we didn't have a chart for it, but you can also find the supplement of an angle, which is the other angle that would add to 180 degrees, by subtracting its measure from 180 degrees. And down here is just an easy way to remember complement versus supplement. It's always right to give a complement. Right angles are 90, right? Or you can kind of just mention what I already mentioned beforehand, which C before S, 90 before 180. So again, really honing in here on the vocab. Complementary angles, two angles that add to 90 degrees. Supplementary angles, two angles that add to 180 degrees. All right, let's do some practice problems. All right, so example number 1, find the complement to angle M. Well, here's how we're going to do it. Again, we're trying to find complement here, so we're trying to find the other angle that adds to 90 degrees. So what we're going to do is we're going to take 90 degrees, and I'm going to subtract the measure of angle M, which in this case would be 90 degrees minus 26.8 degrees, which if I subtract those two, I am going to get 63.2 degrees. So we say that the complement to the measure of angle M is 63.2 degrees. Okay, now finding the supplement to angle N, and we are given that angle N is 2y plus 20. All right, so we can actually come up with an expression. I know we don't know what angle N is, or we don't know what the measure of angle N is, but we can still come up with an algebraic expression. So now, be careful, I'm trying to find the supplement. Now we're finding two angles that add up to 180 degrees. So to find the supplement, I'm going to take 180 degrees, and I'm going to subtract my 2y minus 20 degrees, which is, I should have wrote an algebraic one first. I'm sorry, it should have been 180 minus the measure of angle N. So we go here, right? This is just some basic algebra. Now remember, right? I don't know what y is, so I'm not going to be able to find it here in this case. But distributing the negatives, this will be 180 minus 2y plus 20, because negative times a negative is a positive. And we're just going to combine like terms, so we would have 200 minus 2y, and we can put that in parentheses. So the measure of my complement equals 200 minus 2y degrees. Why is that not matching? Oh, because I'm dumb. Okay, real quick, I apologize. I don't have time to re-edit this, okay? This 20 was positive. So that's going to make this negative, which instead of the 200, it's going to make it 160. My bad. You know, this wouldn't be a Mr. K video if I didn't screw up, and I really don't feel like recording this. So anyway, real quickly, 180 minus 2y plus 20, distribute the negative, you have negative 2y minus 20, and then you're going to have 160. Sorry about that. Hopefully you caught it beforehand, but quick fix. My apologies. Let's move on. Okay, here's an algebraic problem. An angle measures 3 degrees less than twice the measure of its complement. Find the measure of its complement. So our job is to find the measure of the complement. We're given some information. So first off, right, we're trying to find the complement, so let's go ahead and let's define our variable as x being the measure of the complement. Okay? Measure of the complement. So if I'm looking at this, I have to set up an algebraic expression, right? So I am given two angles here, okay? I am given an angle that measures 3 degrees less than twice the measure of its complement, okay? So let's think about an algebraic expression we can come up there. That would be 2x minus 3, all right? So I'm given an angle that measures 2 times the complement subtracted by 3. 3 degrees less than twice the measure of the complement. This part is the 2x, because we just said let x be the measure of the complement, and then this is taking 3 degrees off, all right? So if I take that angle, we don't know what that angle is, and add x, so add x degrees, all right? You don't necessarily have to put the degrees here. But if I take this, right, this is the original angle. And then this would be the complement. Those two, since they're complementary angles, are going to equal 90 degrees. So what I'm going to have is 2x minus 3 plus x equals 90 degrees. All right, now I can solve 2x plus x is 3x. So we have 3x minus 3 equals 90 degrees. So add 3 to both sides. 3x equals 93. Divided by 3. And x is going to equal 31 degrees. That means that the measure of the complement is 31 degrees. And we're not asked, but we can also find the original angle, right? The original angle is the other angle that's going to add to 90 degrees. So we could take 90 minus 31 and say, well, the original angle has to be 51 degrees. Or 59 degrees, because 90 minus 31 is 59. All right, so nice little way, again, you know, kind of one of those things where there's, you know, algebra really hidden in. All right, some more vocab, and we're talking about angled pairs here. All right, so let's talk about adjacent angles. All right, adjacent angles are two angles in the same plane, all right, so two angles, just imagine any flat surface, with a common vertex and a common side, but no common interior points. So, whoa, do we have a lot going on here? All right, so the best way to do this is with the drawing. So angles 1 and angle 2 are adjacent angles. Why? Well, they're next, adjacent commonly means next to, right? But we need more than that, right? So if I'm looking at this, right, I have a common vertex right here that I'm highlighting in blue. That is my common vertex, right? Now remember, the definition of an angle is two rays that share a common endpoint. So in this case, angle 1 is represented by this ray and this ray, and I can't name those rays because I'm not given anything. And then angle 2 is represented by this ray as well, and that ray. So if I'm looking at it, right, let's think of the definition. What do we need for two rays, or I'm sorry, for two angles to be adjacent, right? Well, they need to have a common vertex here. So notice how both my blue angle and my green angle share this common vertex right here, which will then, I'm gonna do it again. I'm gonna denote in purple, right? So common vertex, awesome. And then they need the common side. So a common side, remember, a common side is actually a ray, right? So we need a common ray here. And if you look here, and let's just get my highlighter, okay? My common ray is this guy right here that was shared by the blue and the green. I know it just turned black, but that's my common side. So boom, got that. But no common interior points. So basically what that means is there's no points here in the middle. Like I don't have a point here, I don't have a point here. But so these 2 points, these enough are allowed to say that these two angles, angles 1 and angle 2, are adjacent angles, right? Common vertex, common side. All right, next vocab word, a linear pair. All right, now this can be tricky at first, but let's go through it. It is a pair of two angles, right, that are both adjacent. All right, so we need a common vertex and a common side, and supplementary, which means they add to 180. All right, so here's an example. All right. We are given angles 4 and 3. Angles 4 and 3 form a linear pair. Well, let's talk about why. So first off, right, I want you to understand, okay, and the word and means you need both of these conditions to apply. You can't have one or the other. If I'm looking at this, right, adjacent, all right, let's go back real quick. Let's go back. So adjacent, we need common vertex, common side, no common interior points. Do we have that here? Yes, we do. They share a common vertex right here. So there's your common vertex. Yay, smiley face, right? And do they have a common side? They do. They share this side right here. That is the worst straight line ever. Okay, but angle 3 is over here, angle 4 is over here. Boom, adjacency is checked. Now, how can we tell that they add to 180 here? Well, if you remember from section 1.2, right, a straight line or a straight angle must equal 180 degrees. So really what you're doing is you're looking for a straight line here. So if I look at, let's get a different color highlighter here. I have a line here, okay? That's a straight line. So see how both angles 4 and angle 3 are on this straight line here? So that means this is a straight angle. That means if I add in angles 3 and angle 4, I'm gonna have supplementary angles. So that is something to keep out for, all right? Now remember, for a linear pair, you need both adjacency and supplementary. You can't have one or the other, right? Again, you can have two angles. So if we go back here, right, these two angles are just adjacent. They definitely don't form a linear pair because I don't have a straight line here. I don't have this blue line extending on back and forever, right? Or this green line extending on forever. I would need more here. So these two angles are adjacent, but they don't form aren't supplementary. And again, if I go back to the very definition of supplementary, right, we've said that, hey, angle C and angle A, those are supplementary, but they don't form a linear pair because they're not adjacent. They don't share a common vertex, right? Here's my common vertex here and common vertex here. So, I'm sorry, those are vertexes. They're not common, right? They don't share it, right? If I stuck this, right, if I were to move this guy right here and then extend the line out and maybe call this 127, then I have a linear pair. But I don't, so I'll just get rid of that. So let's practice them, okay? Tell whether the angles are adjacent only, adjacent, and form a linear pair. All right, so you're gonna get practice problems like this all the time, and it's just a matter of checking here. So let's go ahead and find. So angle 1 and angle 2. So first off, let's find those angles, right? So here's angle 1, formed by that ray and formed by that ray. There's angle 1. Angle 2, which let's go ahead blue. Here's one ray and here's another. All right. So looking at it, are they adjacent? I would say they absolutely are because we have a common vertex right here. They share a common side, so they are adjacent. But do they form a linear pair? Do you see a straight line here? So for a straight line, don't look at the common side. So we have to look at just the blue or just the green. Do I see a straight line extending here? No, I don't. So these guys are just adjacent. Adjacent only. All right, so I'm going to go ahead and erase this. All right, now let's go ahead and look at angles 2 and 4. So if I'm going to go back to my highlighter here. So if I go back to my highlighter, so now I got angles 2 and 4. So I'm going to go, well, we just used angle 2, so we know where that is. So here's angle 2, right? And angle 4, which will go blue, right here, right here. So that's these two angles, all right? So first off, okay, are they adjacent? Well, they do share a common side, but do they have a common vertex? And that answer is no, because here is the vertex for angle 2, here is the vertex for angle 4. So by definition, they're not adjacent, right? So if they're not adjacent, then they can't form a linear pair because, again, for a linear pair, you need both adjacent and supplementary. So I don't even need to check to see if they're supplementary because they're not adjacent. So you can just say, well, they're not adjacent. So if they're not adjacent, they can't be a linear pair. All right. Some more erasing in here. All right. So if we're looking here, let's go ahead and look at angles 1 and 3. All right. So angle 1 is again right here. That we've already highlighted before. And then angle 3 is going to be this way and this way. All right, checking for adjacency. So if I'm checking for adjacency, do I have a common vertex? I do. It's right here, right? So they have a common vertex. Do they share a common side? Boom, cool. They're adjacent. They form a linear pair. So are they also supplementary? Do you see a straight line or opposite rays being formed? So again, do not look here. Don't look here at this common side. You want to look at the other two. So I have a green going off in one direction. I have a blue going off in another. Cool. We have a straight line here. So angles 1 and angle 3 are supplementary. So you do have a linear pair here. So you can say adjacent and form a linear pair. Eventually, you can just say linear pair, because if you're telling me linear pair, I know you know they're adjacent. But for now, you can write that. All right, and let's do the last one. I would recommend pausing the video here and trying it yourself to see if you can get the hang now that you have an example of each. But so go ahead, pause it right here just for a second, try to do these two angles, and then we'll do it together. Okay, hopefully you paused. Again, I really hope you did, just to go from there. We'll do EBA in green, so angle EBA, so that's this guy. Okay, why did you do that? That's this guy. And then in blue, we'll do ABC. So A, B, and C. So ABC is just that entire straight line. All right, so do we have adjacency? Let's figure it out here. Do they share a common vertex? They do, which is right here. And they have a common side. So they are adjacent. They are adjacent. Do they form a linear pair? So are they supplementary? Do these two angles add up to 180? And well, that's not the case here, because you see how angle ABC is just this line? So we already know this angle is already 180. It's already 180 by itself. So the only way this could be, these two angles could be supplementary is if this guy was 0. And I know I said, hey, this is bad geometry. We can just look at it and know, okay, this angle's right here. Let me just get green here so we keep the color code. This angle ABC, this is not going to be 0 degrees. So we know 180 plus some positive number is going to be bigger than 180. So this is not supplementary. So you can't say they are adjacent, though. So adjacent only. All right. Last thing we really got to talk about is the concept of vertical angles. All right. So vertical angles here are two non-adjacent angles, so non-adjacent, formed by two intersecting lines. Okay. So if we're looking at this diagram here, all right. So vertical angles is going to be one of those things in this class you're going to be sick of by the time of, but it's a very easy concept. So vertical angles. All right, so first off, what you need is you need two lines that intersect. All right, so I'll even draw the intersection right here. Okay, we know nothing about these lines other than the extend forever. So, the vertical angles here are formed by two intersecting lines are the two non-adjacent. So if we look at angles 1 and angle 3, they are not adjacent. Now I know you're looking at it like, well, wait, Mr. K, they're right across from each other. They can't be. Well, they're not next to each other, right? So if I look at angle 1 and angle 3. They do have a common vertex, but they don't share a common side. So here's angle 1 that's formed by these two rays, right? And angle 3 is formed by these two. They don't share. None of these are shared, okay? And actually, every time you have two intersecting lines, you're going to create two pairs of vertical angles. So angles 1 and 3 are vertical angles, and angles 2 and 4 are vertical angles. So that's what it is. So 1 and 3 are two vertical angles, 2 and 4 are two different vertical angles. Now, what's so special about vertical angles? Well, they're actually congruent. So time for our first theorem in this class, okay? Just so you guys know what a theorem is, how it's different from a postulate. So we talked about postulates are kind of the captain obvious statements that we don't need, that are generally accepted as true without proof. Theorems require proofs. Now, don't want to scare you. We're not going to prove this theorem right now. We will prove it next chapter. But just keep in mind. So the big thing about vertical angles is, all right, so the definition is that they're two non-adjacent angles formed by two intersecting lines. But you have now this in your vocab is going to be different. You're going to have a vertical angles theorem, and all this theorem says is that vertical angles are congruent. Again, if I come back to this, right? Not only are angles 1 and 3 congruent vertical angles, angle 1 is actually congruent to angle 3, and if I switch colors, angle 2 is congruent to angle 4. And if I wanted to draw some arc marks to represent that, it's kind of tough with the ones there, but I would draw one arc mark for 1 and 3, and then I would do two arc marks for 2 and 4. And the reason why I'm doing two arc marks is because 1 and 3 are congruent, 2 and 4 are congruent, but that doesn't necessarily mean that 1 and 2 are congruent and 3 and 4 are congruent. We want to just distinction and uniqueness. All right, so let's look at this. Write a congruent statement based on the diagram, then use it to solve for x. All right, so this is a problem that you might see in your homework here. So we're given two lines, line AB, I'll just write it out, right? Line AB, and line AC. Line AC, and we're given line BD, and they all intersect at point Q. Not that we really need to write any of this down, it's just, kind of what we're given here, all right? So we're given, I'm just writing off what we're given, that the measure of angle AQB is equal to 6x plus 2 degrees. And we're given that the measure of angle DQC is equal to 44 degrees. So this is it, everything we were given here. All right, well, this is where it kind of helps to play with vertical angles, because if I look at it, right, these two angles here, and I'll do it by a highlighter, are vertical angles because they are non-adjacent and they're formed by two intersecting lines. So what that means is these two angles are actually both going to be 44 degrees. All right, so we have this has to be 44 and this has to be 44. So basically what I'm going to do is I'm going to take the 6x plus 2 and I'm going to set it equal to 44 degrees because they're congruent. So on your homework, this is what I would expect, right? We need a congruent statement first. So we could say, hey, the measure of angle AQB is congruent to the measure of angle DQC. And what I would basically ask is, for the justification, you can say vertical angles theorem. Ooh. Get out of here. So if I had a justification spot, okay? Now this is all we'll have from 1-3, all right? If I know two things are congruent, I can say their measures are equal. So this is actually bad. Right? Angle AQB is congruent to angle DQC, which means their measures are equal. So the measure of angle AQB is equal to the measure of angle DQC. That's just definition of congruence, right? Definition of congruence. I'm shorthanding there. So now I can say 6x plus 2 is equal to 44. In basic algebra, 6x equals 42. So x is going to equal 7, because if I divide both sides by 6. And we're done, because solve for x. It's kind of pointless. You don't need to plug back in, because you know this is going to be 44 degrees, because these two have to be equal. But this might be something you have to solve for x here. All right, so hopefully that's all right. The nice thing about a video is you can go back and check anything. Let's go from there. In Blackboard, there is a set of completed notes as well. But now what's going to happen is, this, if you're in class, the stuff's going to give you a classwork. You go do some practice problems where I'll put a key on Blackboard. Go from there. But the homework will also be passed out at the end of class. So two things for your homework. Homework 1.4 will be due next time. And I would make sure you keep adding on stuff in your vocab sheet. But that's all from me. Hopefully everything is okay. Email me if you have questions, and we'll see you next time. All right, take care.